Alright guys, we're ready to get started on section 1.1. Exponents, order of operations, and inequality. Let's look first here at the beginning of the section where we are reminded in the form of a review of exponents or powers. When you have a number that is raised to some power or exponent, it indicates repeated multiplication. In other words, 2 raised to the third power, or 2 cubed, means 3 factors of 2. 2 times itself 3 times. Remember, in algebra we use a dot for multiplication. So we have 2 times 2 is 4, times 2 is 8. 5 raised to the second power, or 5 squared, means 2 factors of 5. 5 times itself. 5 times 5 is 25. Go ahead and get used to circling or boxing your final answers, because this will be required on quizzes and tests. Let's look at some homework problems. I'm looking on page 33 here in the exercises for section 1.1. Let's have a look at number 24. The instructions: find the value of each exponential expression. Now, on a quiz or a test, I may simply say evaluate, which is what she's saying. She says find the value of each expression. That's what evaluate means. To find a value. To boil the expression down to a single number. So number 24 wants us to evaluate 6 to the 4th power. 6 to the 4th power means 4 factors of 6. 6 times itself 4 times. That one's not quite as easy to do in our head as the last couple. So I'll come over and do some scratch work. 6 times 6 I know is 36. Times a third 6, we've already got 2 of them. Here's my third 6, multiply. 6 times 6 is 36, carry a 3. 3 times 6 is 18, plus that 3 is 21, so 216. And then we need our 4th factor of 6, so we multiply. That gives me a 6, carry a 3. 6 times 1 is 6, and 3 makes 9. 6 times 2 is 12. So my answer here, 1,296. Now, because we are not working with calculators on quizzes and tests, this is about the limit of this kind of problem that I would give you. I certainly expect you to be able to do this, but I'm not going to ask you to find 7 to the 8th power. I mean, that could take half the class period just to do that one by hand. So on quizzes and tests, they will be simple enough, good enough to know that you know what you're doing when I grade it, but easy enough to get through in a reasonable time. All right, let's look also now at number 30 in this same batch of problems. Still under the same instructions, evaluate. We want to look at what is 3/4 raised to the 3rd power. This is 3/4 times itself 3 times. Recall that to multiply fractions, we multiply the tops and we multiply the bottoms. And so here, across the top, 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. And in my denominators, 4 times 4 times 4. 4 times 4 is 16. And 16 times 4, 64. If you need to come over to the side and do a little scratch work, that's fine. We make sure when we get a fraction for an answer that it is reduced. that the numerator and denominator share no common factors that we could divide out. This is reduced to lowest terms. Put a box around it. So that's just a quick review of exponents. Let's go ahead and be reminded that when I have an exponential expression like 4 to the third power, the 3 is called the exponent or the power. And the 4, do you remember what it's called? In an exponential expression, the thing being raised to a power is called the base. And that is a term we're going to hear the rest of the semester. And it is an important concept, as we'll see in future sections, to be able to identify the base of an exponent. So some terminology you need to be familiar with. Anytime as you're reading through your textbook, pay attention to those bold-faced terms. Many of them I'll point out as we go along. But as you read through the sections, be sure and pay attention to the terminology that's used and the language that is associated with this algebra. Let's review now the order of operations. Now, many of you have heard of PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. PEMDAS. I'm not a fan of explaining it this way. For one thing, it leads us to believe, in some cases, that multiplication comes before division. That's not what this means. Multiplication and division hold the same rank in the order of operations. Addition and subtraction hold the same rank in the order of operations. If you have your textbook, you can join me on page 29. If not, just make a note to go back and look at this when you do get your book. Page 29, there's a blue box in the middle of the page. Order of operations. It says, if grouping symbols are present, work within them innermost first, and what? Above and below fraction bars separately. Get this in your head. Fraction bars are grouping symbols. Fraction bars indicate division, we know that. But fraction bars are also grouping symbols. For example, if I had 8 plus 4 over 2. Well, this is a division problem. The fraction bar is really just a little division sign. But it is also a grouping symbol. In other words, we have to simplify the top, simplify the bottom, and then finally we can divide what we get. In the top, 8 plus 4 is 12. In the bottom, that's already simplified. Now we can carry out the division indicated by the fraction bar. 12 over 2, 12 divided by 2 is 6. 6 over 1, but we never leave a final answer over 1, because 6 divided by 1 is just 6. So 6 over 1 is not considered simplified. Back to the blue box. It says above and below the fraction bar separately, and in the following order. It says step 1, apply all exponents. Step 2, carefully, it says do any multiplication or division in order from left to right. Multiplication and division have the same rank. You take them as they appear from left to right. Step 3, after all your multiplication and divisions are dealt with, you're ready to finally do additions or subtractions in order from left to right. So we see where this PEMDAS comes from, parentheses, exponents, multiplication and division as they appear from left to right, addition and subtraction as they appear from left to right. But I've seen another instructor use this abbreviation, which makes a little more sense to me. I don't know how you want to pronounce that. Gema, Gema, Gemma, whatever. But this reminds me that the order of operations says work in grouping. Grouping symbols first. Exponents hold the next rank. Multiplication, which is just what? The inverse of division. So the M reminds me of multiplication and division. The A, addition and subtraction. Addition and subtraction are just two sides of the same coin. One goes up, one goes down. So, grouping, exponents, multiplication, which includes division, addition, which includes subtraction. This may be a better way to approach this idea of the order of operations. Whatever works for you. Join me once again in the homework, back on page 33. Let's grab another even-numbered problem. Of course, I'm saving the odd problems for you, for your homework. And number 36. She says, find the value of each expression. Again, on my quiz or test, I will likely just say, evaluate, which means the same thing. Find that value. Boil it down. Evaluate 11 plus 7 times 6. Let me take a moment here simply to remind you that I could write this just as easily as 11 plus 7 times 6. Because in algebra, if we have two expressions side by side with no operative symbol between them, we understand that the operation is multiplication. So these mean exactly the same thing. I will never again have to remind you, and I won't, on a quiz or test, remind you of the order of operations. When I say evaluate, you understand that from this point forward, we are under the order of operations. And so, when we're asked to evaluate, we say, okay, what all is going on here? I have an addition, I have a multiplication. What should be done first? Multiplication comes before addition in the order of operations. So the first thing I'll do is carry out this multiplication. We have 11 plus this product. 7 times 6 is 42. And then the only thing left to do is add. And that's going to give me a total of 11 plus 42 is 53. Get in the habit of circling or boxing your answers. Let's look at another even number problem, now number 40. Under the same instructions, evaluate. We've got some fractions in this problem, so another good chance to review how we work with fractions. And again, as mentioned in class, sections R1 and R2 at the beginning of your textbook are review sections for fractions and decimals if you need to go back and get back up to speed on working with fractions. Evaluate. Of course, we're under the order of operations, and so we're going to carry out the multiplications before we do the addition. Now, would you agree with me that I can do both of the multiplications in this one first step? Because they are independent of each other. In other words, one is not waiting on the answer from the other so that it can be done. If I were to do this multiplication on the far left first, the very next step would be what? To do this next multiplication. So I'm going to knock these both out in the same step. When I multiply fractions, I multiply the tops, multiply the bottoms. But do you remember what I can do when I'm multiplying fractions that I cannot do any other time, only under multiplication? I can do what's called cross-canceling. I can cross-cancel any factors common to the top and bottom of the problem. I can pre-reduce, in other words. I can reduce ahead of time, but only when I'm multiplying. You see this 9 and this 3? They're both divisible by 3. 3 goes into 3 once. 3 goes into 9 3 times. And so I can knock those down by a factor of 3. You see the 4 and the 2? They both contain a factor of 2. 2 goes into 2 once, 2 goes into 4 twice. So I can divide both of those by 2. Something in the top with something in the bottom. Even if they're in the same fraction, please understand, cross multiplication does not mean on a diagonal. It means across the fraction bar, canceling something in the top with something in the bottom of the problem, of the multiplication problem. So even if it's in the same fraction, I mean, you can always reduce a fraction, right? So something in the top with something in the bottom. Now that I have cross-canceled everything I can see that needs to be cross-canceled, I'll multiply the tops. 3 times 1 is 3. Over 2 times 1 is 2. And plus, let's pause here a moment and notice if I had worked this without cross-canceling, I would have had what? 9 times 2 is 18. In the bottom, 4 times 3 would have been 12. And then what can you do? Reduce that. Reduce that by a factor of 6. Divide the top and bottom by 6, and what's it give you? 3 halves. It gives you 3 halves. But by cross-canceling, it is already reduced when I get there. So long as I've cross-canceled everything that's possible to cross-cancel, the result will already be reduced to lowest terms. I encourage you to get used to cross-canceling, because when we get to chapter 6, I mean, right now it's an option. You can cross-cancel like I did, or you can go this route, which usually gives you numbers that are bigger than you need to be working with. I'd rather make my numbers smaller as I work these problems than to make them bigger and have to reduce. Right now, though, it is an option. In chapter 6, when we get to those algebraic fractions, cross-canceling will be a necessity. It will not be an option. So go ahead and get used to the idea of cross-canceling. Continuing our problem, we've taken care of the first multiplication, and we said in this same first step, I can deal with this second multiplication. Well, when multiplying fractions, let's see if I can cross-cancel. I see these 5s. Now, honestly, guys, when I cross-cancel, I don't usually write the 1s because they don't do anything. If I had not written the 1s here, what would I have had? 3 over 2? That's what I got. So over here, 5 goes into 5 once, 5 goes into 5 once. That's the way I would write it. If you like seeing these 1s, help yourself, that's fine. But I typically don't write the 1s when I cross-cancel. If you did not write the 1s, then the only thing that survived was a 4 in the top and a 3 in the bottom. If you did write the 1s, multiply the tops. 4 times 1 is 4. Multiply the bottoms. 1 times 3 is 3. We're down to the last operation that needs to be dealt with. We need to add. To add or subtract fractions, you must have what? A common denominator. What is the least common denominator for halves and thirds? These can both be turned into sixths. How do I turn a 2 into a 6? Through multiplication. I need a factor of 3. Multiply the top and bottom by 3. Why do you do that? Because you're multiplying by 3 over 3, which is 1. 3 over 3 is 1. This big pink thing right here is just a 1. And something times 1 is itself. I'm going to change the way this fraction looks, but I will not change its value. 3 times 3 is 9. 2 times 3 is 6. 3 halves is the same as 9 sixths. If you had 3 halves of a pizza, or 1.5 pizzas, it'd be the same as if you had 9 sixths pizzas. So I changed the way the number looked, but I did not change its value. We need to get this fraction into sixths. That's going to require a 2 in this denominator. I need to reflect that in the top, also with a 2. And this is going to give me, in the top, an 8, in the bottom, a 6. I now have common denominators. To add fractions or subtract, you add the tops and write that result over this common denominator. It'd be like saying you've got 9 gallons plus 8 gallons 9 inches plus 8 inches, what's that going to give you? If I add 9 inches plus 8 inches, does that give me 17 inches? No, that's silly. So when you add fractions, it's that same idea. You're adding 9 of these things, 9 of these sixths, plus 8 more of these sixths is going to total 17. 17 what? 17 sixths. Make sure that this fraction is in lowest terms. Do you understand what I mean by lowest terms? I mean that there is no factor common to the top and bottom. I can't divide the top and bottom by the same thing and get smaller numbers. This fraction is in lowest terms. Now, because it's top heavy, we call it an improper fraction. And that is unfortunate because there's nothing wrong with an improper fraction. In fact, in algebra, we prefer an improper fraction to a mixed number. You could certainly divide this out. 6 goes into 17 twice, remainder 5. So this is the same as 2 5/6. And I'll certainly accept that as an answer. There's nothing wrong with that. But there's really no need. We're done when we've got 17 sixths. It is in lowest terms, can't be reduced to any smaller numbers. And in algebra, we will discover that these improper fractions are far preferable to dealing with mixed numbers in most situations. I would just leave that as 17 over 6 and be done with it. Let's look at number 54. In number 54, again, the instructions read, evaluate. Now, the first question I have for you is how many sets of grouping symbols do you see? How many sets of grouping symbols do you see? There's only one. Just the square brackets. Why do I say that? The parentheses aren't grouping anything. The parentheses are doing what here? They're indicating multiplication. In fact, no need to change this in your notes, but I could have written the problem like that, and it would be the same thing. Do you see that there's really only one set of grouping symbols? These parentheses aren't grouping this time. They're operative symbols indicating multiplication. So we're going to start by working inside the set of grouping symbols, inside the square brackets. And inside the square brackets, we have a choice. Do we add or do we multiply first? And tell you what I'd like to do. How about you pause the video right here, give this one a try yourself, and when you've got it down to an answer, start the video back up and I will work it out for you. And we'll compare answers. So we said we're going to work inside the square brackets first. And in the square brackets we have a choice. Add or multiply. By the order of operations, we multiply before we add. So the first thing we'll do here, 7 times 3 is 21. If you wanted to, you could change these square brackets now down to parentheses. It doesn't matter. We still have things to do inside the grouping symbols. So we will continue inside the square brackets. We add to get 1 plus 21 is 22. We're done with grouping symbols. In fact, I could have written this just as easily as what? 4 times with a dot. Or I could have used parentheses. But we're done with our group. We're done working inside grouping symbols at this point. So now we look at the rest of what we have here. And again, we have a choice. Add or multiply. Multiply outranks adding in the order of operations. So multiplying 4 times 22 is 88. And finally, the only thing left to do is this addition. 5 plus 88, a total of 93. I will point out to you here that a common mistake is to add this 5 plus this 4. and then multiply times the result. Well, that's not how this works. This says 5 plus 4 times something. Before you can do this addition on the outside, you would have to know the answer to this multiplication. And so don't add that 5 plus 4. They're not grouped. That's 5 plus 4 times something. It turns out the something is this 22. And we have to multiply 4 times 22 before we ever consider adding that result to that 5. How'd you do? Let's do another one. Number 60. Evaluate. All right, we have a big fraction bar here. We know the fraction bar indicates division, but what? It is also a grouping symbol because we have to work above and below the fraction bar separately. Only when we have it boiled down in the top, boiled down in the bottom, can we then perform the division indicated by that fraction bar. So in the top, what are we going to do first? We're going to work in the parentheses, and in the parentheses we have a power and a subtraction. We'll do the power first. 8 squared, 8 times itself. 8 times 8 is 64. And that's all we'll do on the top in this first step. Over, let's jump to the bottom and get a little of that out of the way. We have our choice, subtract or do a power. We'll do the power. 29 minus 3 cubed. 3 times 3 times 3. 3 times 3 is 9, times another 3 is 27. Jump back to the top. In the top, we're still dealing with what's in the parentheses. So we will finish that off. 64 minus 4 is 60. Here again, if you want to write that as a dot for multiplication, because that's all these parentheses indicate now, is that I need to multiply. There's no more grouping symbol being used in the top at this point, right? Jump to the bottom. The only thing left to do in the bottom is subtract. 29 minus 7 is 2. Jump back to the top. In the top, we now have a choice of what? Multiplying or adding. Multiplication outranks addition in the order of operations. So we'll multiply 2 times 60 is 120. In the bottom, there's nothing left to do. Just copy that 2. Finish off the top now. 120 plus 8 is 128. 128 over 2. This will actually divide out evenly. 128 divided by 2, in other words, half of 128, is 64. When I get this boiled down to a single fraction, okay? Let's just say, for example, that I had worked a problem and I got down to my next to the last step, and I had, let's say, 30 14ths, 30 over 14. And I will turn to you and I will say, class, what is 30 divided by 14? What is 30 divided by 14? Well, it won't divide out evenly, so what are you responsible for doing? You are responsible for reducing this to lowest terms. And by a factor of 2, divide the top and bottom by 2. This reduces to 15/7. So when I say, class, what is 30 divided by 14? Your answer will be, that's 15/7. Okay? That's all that means. But be sure that these are in lowest terms. Again, they can be left as improper fractions, and in fact, that is preferred. let's start wrapping up this section and talk about inequalities. Back here in the body of the section, on page 31 in the middle, Objective 4, know the meanings of not equal to, less than, greater than, less than or equal to, and greater than or equal to. These are called inequality symbols. And so the discussion there on page 31, I want to make sure that we understand this is something most of us are very familiar with. Of course, not equal to, you would agree with me, 2 is not equal to 3. That is a true statement. I'm sure you would agree with me that 2 is less than 3. That is a true statement. I want to evaluate the truth of this statement. 2 is greater than 3. Certainly that's false. Now, I want to make sure that we have no misconceptions about this statement. 2 is less than or equal to 3. True or false? Well, that's true. It says less than or equal to. As long as it's one of those, we're good to go because it said or. 2 is less than or equal to 3. Yes, that's true because it's less than. Well, then what about 3 is less than or equal to 3? True or false? Well, that's true because it's equal to, and we said or. 3 is less than or equal to, and it is equal to itself 3, so that's true. How about 4 is greater than or equal to 5? True or false? Well, 4 is not greater than 5, and 4 is also not equal to 5. So this is a false statement. I just want to be sure that we're clear and have no misconceptions about what these compound inequalities indicate. Less than or equal to, greater than or equal to. It's an or statement. So as long as one part of that is true, then your statement is true. Your book is going to have you work problems like number 72. So return with me now to the homework set. We'll grab number 72. The instructions. It says first simplify both sides of each inequality. The left-hand side here is everything to the left of this inequality symbol. The right-hand side is everything to the right of this symbol, so just the 48. It says simplify both sides and then determine whether the statement is true or false. So we need to simplify this left-hand side. Right-hand side is already simplified. We follow the order of operations. We don't have to be told that. We know that anytime we are evaluating, we're under the order of operations. We multiply. 9 times 3 is 27. Plus this multiplication. 4 times 5 is 20. Keep going. 27 plus 20 now is 47. We have simplified both sides. And now we are asked to evaluate the truth of this statement. True or false? 47 is greater than or equal to 48. Is 47 greater than 48? No. Is 47 equal to 48? No. So this statement is false. So you will have a handful of those types of problems. It'll let you practice your evaluating and order of operations, as well as keeping you mindful of our inequalities. One thing I would point out, look at number 92 with me. Look at number 92. In number 92, we are asked to determine the truth. Is this true or false? 10/6 is equal to 3/2. Now, strictly speaking, you may be able to just think about this for a minute and decide whether it's true or false. But strictly speaking, in order to compare fractions, they need to have the same denominator. And so I need a common denominator here, which would be 6. So what I'm really asking is it true that 10/6 is equal to 9/6? Obviously, that's false. But if you go to compare fractions, to compare them, they need to be of the same denominator, the same type, the same kind of fraction. And then here toward the end of the homework, she's going to have you work problems like, let's grab number 100. These are very straightforward. In number 100, the instructions say, write each word statement in symbols. Guys, I need you to get your textbooks if you don't already have them, because here in about a week, when we have word statements like this, I am not going to write them on the board. I'm going to assume that you have that statement right there in front of you in your textbook. But this is number 100. She says, write each word statement in symbols. 3 is not equal to 4. All in the world, don't make this tougher than it is. All in the world we want here is to write 3 is not equal to 4. That's all. That's all we have to worry about. So that takes care of section 1.1. So you're ready to grab your homework sheet and look to see what are we going to do here in 1.1. I want you to do 13 to 61 the odds, 69 to 101 the odds, checking your answers in the back of the book, and being ready next time I see you with any homework questions you might have, anything you'd like to see worked out on the board. And of course, on that day, I will also have a few other things to add about this section and what it means later down the road. So, get started on that homework. When you're done with that, you'll be ready to go on to section 1.2.